Okay, this lecture is over multicast routing. So first of all, first question is, what is multicast routing? And the answer is, it is a routing protocol that uses multicast messages to distribute routing updates. That is, instead of broadcast typically. So why should we use multicast messages? Well, there's a couple of reasons. The first and most important is that multicasting is more efficient than unicasting. That is, when we send these out, if they're multicast, they go to the devices that should see those updates. And devices that do not do routing, that do not need to see the updates, do not process the updates, so it's more efficient on them. The other thing is it's more secure. Since the routing updates are just going to particular machines, it's not going to machines that might be able to look at the routing information and possibly misuse it to do some type of denial of service attack, for example. So what routing protocols use multicast? There are several we've already talked about. RIP version 2, that was one of the big changes that we discussed, was the switch to multicasting. OSPF is a multicast routing protocol. We've already discussed that. EIGRP, same thing, we've already discussed it. It uses multicast. BGP, we've already discussed. It can use both unicast and multicast, but it does have a multicast mode. And then the one we haven't discussed is IGMP, which we will discuss next. So IGMP stands for Internet Group Management Protocol. The purpose of it is to manage memberships of host and routing device into multicast groups that are related to routing. The process, it's like 5 steps. The device states its membership information to join a particular multicast group, which we will call X. The second thing it does is the routing device then forwards data packets addressed to the multicast group to only those interfaces which joined messages have been received. So it only sends it to devices that care about the updates, or even down to the interface level. You have something called a designated router, which sends periodic join and prune messages. What that part means is there is a routing tree that is built, so it will add machines and remove machines as appropriate. It does that towards a group-specific device called a rendezvous point for each group that it's a member of, so it can actually be a member of multiple groups. Each routing device along the path from the device that's sending the update to the rendezvous point builds what's called a wildcard, or any source state for the group, and sends joins and prune messages along the way towards the rendezvous point. Route entries in IGMP can include source address that sent the update, the group address that it's going to, incoming interfaces on the routers which are packets are being accepted on, outgoing interfaces where packets are sent, timers, and flag bits. So those are the things that the route entry can contain. And then finally, this process creates a shared rendezvous point centered distribution tree that reaches all group members that are included in the group that we were calling X. So that's a quick discussion on the IGMP multicast routing protocol.